अच्छा बच्चों, काइनेमेटिक्स और डायनामिक्स के पास पेपर जो मैंने आपको सॉल्व करने के लिए दिए थे, वो मैं अपने आप को सॉल्व करते हुए रिकॉर्ड करने लगा हूँ ताकि आप लोग अपना काम चेक करने में आसानी हो। और जब भी आपको कोई प्रॉब्लम हो तो आप पास पेपर आराम से जो है वो रेफर कर सको कि इसका सोल्यूशन जो है वो क्या था। तो आई थिंक रिकॉर्डिंग जो है वो आपके काम आएगी। ठीक है, सो आई स्टार्ट विद दिस क्वेश्चन which is from May June 2019, paper 2-1, question number 1। वो उसके अंदर आपको कह रहा है कि फिगर दिखाया हुआ है, उसके अंदर चार फोर्सेस ए बी सी डी जो है वो आपको डायग्राम पे बना के दी गई है, बट दे हैवंट टोल्ड यू व्हिच फोर्सेस आर दीज। एंड पार्ट ए सेज ड्रॉ अ लाइन फ्रॉम ईच बॉक्स ऑन द लेफ्ट टू द करेक्ट डिस्क्रिप्शन ऑफ ईच फोर्स। तो बेसिकली आपने सिर्फ ये फिगर आउट करना है कि कौन सी फोर्स कौन सी है। लेट्स सी, ड्राइविंग फोर्स आपकी कौन सी हो सकती है। ऑब्वियसली ड्राइविंग फोर्स इज द वन व्हिच इज टेकिंग द कार फॉरवर्ड, सो इट्स गोइंग टू बी बी। ओके, कॉन्टैक्ट और नॉर्मल फोर्स। नॉर्मल फोर्स इज द वन जो कि ग्राउंड गाड़ी पे लगा रहा होता है ऊपर की तरफ, सो दैट वुड बी योर फोर्स ए। Air resistance and friction. Air resistance and friction are the forces which are two resistive forces when the car drives forward. ये दो forces जो हैं वो गाड़ी के motion को oppose करती हैं. These two forces always oppose the motion of the car. So if the car is moving forward, these two forces will be backward. So obviously ये force D होगी हमारे पास. And then the force of gravity is the weight which is always acting downwards. This is going to be C. Part B. The table shows the sizes of the forces acting on the car. So वो जब चारों forces आपको दी हुई थी, बता दिया कि उनके magnitudes क्या हैं. And they're saying that the gravitational field strength G is 10 newtons per kg. Calculate the mass of the car. Now we know that mass और weight आपस में किस तरह related है, इस equation से W is equals to mg। अब इसमें सिर्फ आपको ये देखना है कि weight आपको पता है या नहीं पता। वेट आपको टेबल में वैल्यू दी हुई है। वेट की फोर्स थी आपकी फोर्स सी विच वाज एक्टिंग डाउनवर्ड्स। तो आपको सिर्फ ये देखना है कि सी की वैल्यू क्या है। सी की वैल्यू टेबल में 8000 है। सो सब्स्टिट्यूट 8000 फॉर डब्ल्यू। आई डोंट नो द वैल्यू ऑफ एम एंड आई नो जी इज इक्वल टू 10। तो एम आ गया मेरे पास 800 kg। लेट्स मूव टू द नेक्स्ट क्वेश्चन। द रिजल्टेंट फोर्स ऑन द कार। अब रिजल्टेंट फोर्स का मतलब होता है द overall effect of all the forces which are acting on the car. But we don't have to just sum all the forces. हमें सब forces का vector sum लेना होता है, which means you have to take their direction into account as well. So force C जो थी वो मेरे पास 8000 थी, force A भी मेरे पास 8000 थी। इस मीन्स कि ये वाली फोर्स और ये वाली फोर्स ने तो एक दूसरे को कैंसिल आउट कर दिया। अब हमें सिर्फ B और C का इफेक्ट देखना है कि वो एक दूसरे पे क्या फोर्स लगा रही है। तो फोर्स D जो है वो 600 है। Okay, now we move to part 3। पार्ट 3 जो है वो आपसे मांग रहा है कार की एक्सेलरेशन। नाउ रिमेंबर द फॉर्मूला इज F is equals to ma, but the important thing to remember here is this F is not just any force, it's the resultant force, and the resultant force has just been found out in the previous part, which was 400. So 400 is equals to mass of the car, which we found out in the previous part. It was 800, and the acceleration is unknown. So 400 upon 800 will give you is equals to 0.5 meters per second square. Okay, ji. Moving on. At another time, at another time means now you have to forget all the values that you have calculated here. अब यहाँ पे different situation है, कोई और कार है हमारे पास. The car is traveling at a speed u. So गाड़ी की speed जो है वो u है. It then accelerates for 5 seconds with an acceleration of 1.6 and reaches a speed of 20. तो कह रहे हैं calculate the value of u. Basically, all you have to do is use the formula A is equals to P minus U upon T. The car is traveling at some speed and after some time it accelerates and then reaches a new speed. Now we know the final speed, which was 20. We don't know the initial speed. We know how much time it took, 5 seconds, and we know the acceleration, it was 1.6. So all you have to do is just substitute the values into the equation and you will get the value of initial velocity. Q is 12 meters per second. Simple enough. Let's move on to the next question. Okay, so this question is October, November 2010, paper 2-1, question number 2. And again, this question primarily focuses on circular motion, which is also a part of the chapter dynamics. Figure 2.1 shows the planet Venus orbiting the Sun in a circular orbit at a constant speed. A force acting on Venus keeps it moving in a circle. Now, we know that whenever an object is moving at a constant speed and circular motion, there is a centripetal force acting on the object which is always towards the center of the circular path, right? We call it the centripetal force. But that's just telling you about the direction of the force. It's not telling you which force it is. So here in question number part A, they're asking, state the name of this force and the object that causes it. तो पहली बात तो ये है कि वीनस पे फोर्स लगा कौन रहा है. We know that the sun is the object which is causing the force, and force का नाम क्या है? Obviously, what is the force which is attracting Venus towards the sun? It's the force of gravity. It's the pull of gravity of the sun which is attracting the Venus towards, which is causing the centripetal force. On figure 2.1, draw an arrow through the Venus that represents the direction of its acceleration. Okay, so coming back to circular motion, force की डायरेक्शन, जो रिजल्टेंट फोर्स की डायरेक्शन होती है वो हमेशा टुवर्ड्स द सेंटर होती है. तो अगर मुझसे बोला होता कि फोर्स बना है, दैट वुड हैव बीन टुवर्ड्स द सेंटर. और अगर मुझसे कहा जाता है कि इसकी वेलोसिटी को बनाए, तो वेलोसिटी होती है हमेशा टेंजेंट टू द सर्कल. लेट्स से द वीनस इज मूविंग इन दिस डायरेक्शन, वेलोसिटी ये हो जाती है. और जो तीसरी इंपॉर्टेंट चीज है, इन्होंने हमसे यहाँ क्या मांगा है? एक्सेलरेशन. नाउ यू शुड रिमेंबर फ्रॉम न्यूटन सेकंड लॉ that the direction of acceleration is the same as the direction of the force, the resultant force. So अगर आपसे acceleration मांगी है या force मांगी है, both of them are always acting in the same direction. So acceleration is also towards the center. This will be your answer. They haven't asked for velocity, so I'm just going to erase that one. So this is our answer. Acceleration is also towards the center, force is also towards the center, and velocity is tangent to the circle. Part 2. The size of the acceleration is 9.7 into 10 to the power 3 meters per second squared, and the mass of Venus is this, 4.9 10 to the power 24. Calculate the size of the force acting on the planet. Again, you know the resultant force, so you have to calculate the resultant force, and you know the mass and the acceleration. So this is the formula that you use. 4.9 into 10 to the power 24 multiplied by 9.7 into 10 to the power 3. I think this should probably be the answer. I don't have a scientific calculator on my hand yet, so I'm just using the Windows calculator. But I'm pretty sure this should be the answer. Now, you don't forget the units of the force. It should be Newton. Okay, the next one. As time passes, the planet Venus moves a considerable distance around the circular orbit, state why no work is done by the force acting on the planet as it moves. Okay, they're saying as time passes, Venus is covering all this distance. Venus, let's say, goes from here to here. So Venus has covered a lot of distance, thousands and millions of kilometers. But they're saying that no work is done. No work is done on Venus. Now, they're asking you to explain why is that? Why the work done by the sun on Venus is zero. So you remember from the definition of work, it's force into the distance. But there's another important detail here. The distance traveled should be in the direction of the force. So let's say, for example, if this is a box and a force is acting on it, and after some time, the box is here. So the distance that the box has covered is in the direction of the force. But look at our example. The force is acting towards the center, but the velocity or the direction in which Venus is moving is always perpendicular to it. So let's say if Venus was here, force would have been in this direction, but velocity would have been like this. And if Venus was here, force again was towards center and velocity would have been like this. And when Venus is here, force is towards the center, but velocity is like this. So velocity and force are always perpendicular to each other. They're not in each other's direction. And therefore we say that the distance covered is not in the direction of the force. It is perpendicular to the force. So work done is zero. And why is that? Because velocity is always tangent to the circle, while force is always towards the center. So you mention these 2 points, you'll get your 2 marks. Okay, let's move on to the next question. Now this question is from October-November 2010, paper 2, question number 1. Let's see. So figure 1.1 shows a cricket ball as it comes into contact with the bat. The cricket ball has a mass of 0.16 kg. Now the important thing during these solving these papers is, and even in your exam, you should make it a practice to underline all the important details in the question, because that will help you uh, solve your question much quickly, and it will help you not miss out on any important information. It hits the bat with a speed of 25 after being in contact with the bat. So the ball was in contact with the bat for 0.0013 seconds. It rebounds with a speed of 22. The direction is exactly opposite to the original direction. So basically, if this is your bat, the ball comes in, hits, and then rebounds in exactly the opposite direction. This velocity is, I think, 25, and this one is 22, but in the opposite direction. Now remember, when you're talking about velocity, direction is important. So state the difference between velocity and direction, speed and velocity. Speed does not have direction. Speed is a scalar. It only has magnitude. Velocity is a vector. It has magnitude and direction. This is the main difference, and this is what we are going to apply here during this question as well. The change in velocity of the cricket ball. Now this is an important thing. When the ball is traveling towards the bat, it's traveling with a velocity of 25 in this direction, and then when it rebounds, it's traveling with a velocity of 22, but in the opposite direction. The total overall ball की velocity में कितना change है? Now, a good thing to do is with vectors, if one vector is completely on the opposite direction, you take it as negative, and this is what you are going to do. अब किसी भी चीज में जब चेंज निकालना होता है तो आप क्या करते हैं? आप करते हैं फाइनल, जो उसकी फाइनल वैल्यू है, फाइनल वेलोसिटी माइनस इनिशियल वेलोसिटी. ओके, now we have considered our final velocity as minus 22. Why? Because इसकी डायरेक्शन बिल्कुल ऑपोजिट है. माइनस, और उसके बाद इनिशियल वेलोसिटी कितनी थी? 25. बट वी आर टेकिंग दिस एज पॉजिटिव क्योंकि वो हमारी सीधी डायरेक्शन में थी. सो इसका जो डिफरेंस आ रहा है मेरे पास, वो आ रहा है टोटल minus 47. Now because they're asking for change, you don't really need to include the negative sign. You can just say total change is 47 meters per second. Okay, but you have to take the direction into account. The average acceleration of the ball while it is in contact with the bat. So you remember acceleration का formula क्या होता है? V minus U over T. ठीक है? Or you can say change in velocity upon time. I'm using the second one because हम change numerator में change है V minus U वो हम already कर चुके हैं, final minus initial. So total जो velocity में change आया था वो आया था 47, और time जो था वो कितना था? 0.0013 seconds, if I remember it correctly. Let me just check. Yes. So you just make this calculation and you will get your acceleration. And that would be 36153.8. But remember, you have to give your answer correct to 3 significant figures. So जब मैं आंसर में इसको लिखूंगा, my answer should always be correct to 3 significant figures. So I'll round it off to 3 significant figures. That would be 36200 meters per second square. Okay. The average force exerted on the ball by the bat. Again, same formula. F is equals to ma. Now, you know the mass of the ball was provided to you in the question, 0.16, and the acceleration is just calculated in the previous part. Now I suggest, instead of using the rounded off value, use the value which you actually calculated in the previous part, 36153.8. Okay, आपका आंसर जो है वो ज़्यादा एग्जैक्ट आए. It's always advisable to use the complete exact answer of the previous part rather than the rounded off value which I have written in the answer space. So you multiply these two and you will get your answer for the acceleration. Let's check. So this answer multiplied by 0.16, and that will give me my force 5784.6. 5784.6. Again, I'll have to round it off to 3 significant figures when I'm writing it in the answer space. So 5780 Newton. Don't forget the units. Okay. Next question then. This is from October-November 2014, paper 2-1, and this is question number 1 of that paper. Figure 1.1 shows a motorcycle during a race. The motorcycle accelerates along a straight section of the track from speed 40 to a maximum speed. We don't know that maximum speed. So figure 1.2 is the speed time graph along the straight section of the track. ठीक है, तो जब तक वो straight section पर travel कर रहा है, आपका speed time graph आपको दिया हुआ है. And if you look at the speed time graph, उसकी speed 40 से start हो रही है as they have told us, and then the maximum speed we can see that from the graph. So the mass of the motorcycle is 180 kg for the time 0 to 2 seconds. Determine the acceleration of the motorcycle. Okay, so you know the well acceleration formula v minus u over t. Now all you have to do is find the initial speed and the final speed from the graph. So initial speed जब हमारे पास 40 है and 2 seconds पे हमारे पास आकर देखो velocity की value क्या है. This is the value of velocity at 2 seconds. Right between these two. Now you should be able to read your graph to an accuracy of half the smallest box. So let's see. These 5 boxes have a difference of 10 between them. So I'd say one box 10 divided by 5 is equal to the value of 2 meters per second. So 50 के बाद वाला box just 52 and then it's 54 and 54 के बाद वाला 56 है but ये हमारा बिल्कुल 54 और 56 के बीच में है. So our value of final velocity is 55. Okay, so now there are two ways of calculating the acceleration. We have studied that the gradient of the speed time graph is the acceleration, or you can use our formula v minus u over t. But essentially it's the same thing. You are doing just the same thing. अब y2 minus y1 upon x2 minus x1 में भी जब अपनी वैल्यू सब्स्टिट्यूट करोगे आपको एग्जैक्ट सेम एक्सप्रेशन आएगी. So 55 was your final velocity, 40 was your initial velocity, and the time it took was 2 seconds. So 15 upon 2 will give me 7.5 meters per second square. Again, answer space में हमेशा आंसर लिखो and don't forget the units. Okay, the resultant force acting on the motorcycle. Resultant force निकालने के लिए F is equals to ma. Now you know the mass of the motorcycle that was 180 and acceleration we just found out in the previous part. So multiply these two together and you get your answer 1350 Newton. So 13, this is already in 3 significant figures. I don't need to round it off. Just write the unit. One more thing that I would like to advise here is, no matter you don't know the value of any of the quantities which are required, but if you just even know what is the formula that you're going to use in the question, even if you don't know how to solve the question completely, but you know the formula, just always start solving your question by writing down the formula first. F is equals to ma, a is equals to v minus u over t, whatever formula is going to be applied there. So what happens sometimes is that in the marking scheme they have the marks for just writing down the formula so that the examiner knows कि स्टूडेंट को कॉन्सेप्ट पता था एटलीस्ट. तो अगर आपको कुछ भी नहीं पता खाली मत छोड़ो, एटलीस्ट फॉर्मूला लाजमी लिखो एंड इवन इफ यू नो हाउ टू सॉल्व इट स्टिल राइट डाउन द फॉर्मूला सो दैट इवन इफ यू मेक सम कैलकुलेशन मिस्टेक आपको अपने स्टेप्स के मार्क्स मिल जाए क्योंकि आपका कॉन्सेप्ट सही था, आपने फॉर्मूला एटलीस्ट सही यूज किया था. ओके, पार्ट बी. The driving force acting on the motorcycle remains constant throughout the 12 seconds spent on the straight section of the track. Using figure 1.2, figure 1.2 जो हमारा ग्राफ है, describe how the acceleration of the motorcycle changes with time. Okay, तो वो कह रहे हैं भाई कि ड्राइविंग फोर्स जो उस पर आगे की तरफ फोर्स लग रही थी वो तो कांस्टेंट है थ्रू आउट, तो फिर एक्सेलरेशन जो है वो उसकी चेंज हो रही है. पहले तो ये बताओ कि फिगर 1.2 से कैसे पता चल रहा है. नाउ इफ यू रिमेंबर, स्पीड टाइम ग्राफ का जो ग्रेडियंट होता है दैट गिव्स यू द एक्सेलरेशन. वो आपसे पूछ रहे हैं कि फिगर 1.2 से कैसे पता लग रहा है कि एक्सेलरेशन चेंज हो रही है. आप सीधा सीधा फिगर 1.2 को देखो, क्या आपको ग्रेडियंट चेंज होता हुआ नजर आ रहा है? बिल्कुल नजर आ रहा है. I think for the first 2 seconds, this graph is a straight line, and between this part and this part, the graph is actually a curve. So the gradient is changing. The gradient is decreasing. That's all you have to say. How the acceleration changes? How the acceleration changes? Acceleration decreases. How do we know that? We know that because gradient of the speed time graph decreases. Okay. Explain in terms of forces acting why the acceleration changes this way. Now you have to explain in terms of the forces which are acting on the motorcycle, why is the acceleration decreasing, changes this way. Obviously मैंने आपको बताया भी नहीं कि acceleration कैसे change हो रही है, but हमने पिछले पार्ट में आंसर दे दिया acceleration decreases. So हमें forces का concept इस्तेमाल करते हुए बताना है कि उसके ऊपर acceleration जो वो decrease क्यों हुई है. So let's say this is the driving force on the motorcycle. और पीछे की डायरेक्शन में जो फोर्सेस लग रही हैं, लेट्स से दे आर फ्रिक्शन प्लस एयर रेजिस्टेंस, ये फोर्स लग रही है. इस तरह के हमने पीछे भी क्वेश्चन किए हैं, तो वी नो कि पीछे वाली फोर्सेस यही है, फ्रिक्शन एंड एक्सेलरेशन. नाउ दीज टू टुगेदर विल मेक अप द रिजल्टेंट फोर्स ऑफ द मोटरसाइकिल. सो यू रिमेंबर रिजल्टेंट फोर्स कैसे आती है. रिजल्टेंट फोर्स को अगर मैं एफ से रिप्रेजेंट करूँ तो मुझे पता है कि वो ड्राइविंग फोर्स माइनस फ्रिक्शन और एयर रेजिस्टेंस की वजह से आती है यहाँ पे. ठीक है, तो आगे वाली फोर्स जो फॉरवर्ड फोर्स है माइनस बैकवर्ड फोर्स जो है उससे मेरे पास रिजल्टेंट फोर्स आती है. एंड वी ऑल्सो नो दैट रिजल्टेंट फोर्स इज इक्वल टू एम ए. इट मीन्स योर एक्सेलरेशन इज directly proportional to your resultant force. So let's see what is happening to a resultant force. They have told you previously that driving force remains constant. And we know about friction and air resistance that if the speed increases, then friction and air resistance also increase. तो जैसे जैसे उसकी स्पीड बढ़ रही है, फ्रिक्शन बढ़ रही है. जब फ्रिक्शन बढ़ रही है तो इसका मतलब है कि F को क्या हो जाएगा, F will start decreasing. अब अगर F डिक्रीज कर रहा है तो A को क्या होगा, A is directly proportional to it, so A will also decrease. So this is what we have to mention in our answer in proper words. So let's write down this answer. Okay. Why the in terms of force acting, why the acceleration changes this way? Okay. As speed increases, friction and air resistance increases. Since the driving force is constant, the resultant force will decrease. Now, according to Newton's second law, acceleration is proportional to resultant force. So it will also decrease. Done? Now we move to the next question. A girl of Mars. This question is October November 2018 and it's paper 2-1, question number 1. So a girl of Mars, 35 kg, on a bicycle accelerates from rest. This is important. We know now that the initial speed was 0. Travels down a slope in a straight line. The girl does not use pedals. Figure 1.1 shows the gradient of the slope is constant. Calculate the resultant force when she is accelerating at 2.6. So resultant force की equation ma, and her mass is 35, her acceleration is 2.6. So her resultant force is 91 Newton. Okay, let's move on. At first, her acceleration is constant. Okay, so at first her acceleration is constant. At time t1, her acceleration starts to decrease gradually until she's traveling at a constant speed in a straight line. On figure 1.2, sketch speed time graph for the girl when she starts to move until she's traveling at a constant speed. Okay, so now remember, if you remember from the first line, she started from rest and she is accelerating, so obviously her speed is going to increase. But they are telling you that her acceleration is constant. So she starts from rest and her acceleration is constant. So initially it's going to be a straight line. Now the values of the speed are not important. Till time t1 it's going to be a straight line because she's traveling at a constant speed. She's traveling with constant acceleration. Now after t1 her acceleration starts to gradually decrease, but remember it's still acceleration, so the speed is still increasing. But what will decrease now? The gradient of the graph, because this is a speed time graph and the gradient of the speed time graph is your acceleration. So you continue your graph, but you make it a smooth curve of decreasing gradient. So yeah, so this is we are showing this as decreasing acceleration, and then to continue this graph, now she eventually reaches a constant speed. So उसकी speed जो है eventually वो constant हो जाएगी. So you will make this line completely straight. So the graph is drawn in three parts. Part one, where she has speed increasing but with constant acceleration. Part two, where she has again increasing speed but with decreasing acceleration. And then part three, where her speed has become constant. Okay, let's move on to the next part. State how the distance traveled is found from the speed time graph. This is pretty straightforward. In a speed time graph, area under the graph will give you the distance. Okay, so this would be the last question from this chapter. October November 2018, paper 2-2, question number 1. So this question again, I shortlisted all these questions according to each subtopic within these two chapters, और उसी हिसाब से जो है मैं क्वेश्चन सॉल्व कर रहा हूँ. अब क्वेश्चन जो लास्ट है हमारा, it says October November 2018, paper 2-2, question 1. So it shows a satellite traveling at a constant speed in a circular orbit. Now remember हमने circular motion का अभी पीछे एक और सवाल किया. Now this time the circular motion is different. Previously it was Venus orbiting the Sun. Now we have a satellite orbiting the Earth. So define how speed differs from velocity. We just did a similar one previously as well, but I'm just going to write the answer. Speed is a scalar. It only has magnitude, but velocity is a vector. It has both magnitude and direction as well. It has direction as well. Okay, G. As it orbits the Earth, the satellite is experiencing an acceleration. Explain in terms of its velocity why satellite is accelerating. Okay. अब आपसे ये पूछ रहे हैं कि अगर आप पीछे सवाल को गौर से देखो, वो यहाँ पे क्या कह रहे हैं, सैटेलाइट इज ट्रेवलिंग एट अ कांस्टेंट स्पीड. अब हमें पता है स्पीड तो चेंज नहीं हो रही सैटेलाइट की, तो व्हाई आर दे सेइंग दैट द सैटेलाइट, व्हाई आर दे आस्किंग यू टू एक्सप्लेन व्हाई द सैटेलाइट इज एक्सेलरेटिंग. सो इम्पोर्टेंट थिंग टू अंडरस्टैंड इज वेलोसिटी इज अ वेक्टर. अगर ये वाली स्पीड 5 मीटर्स पर सेकंड की है जिसकी डायरेक्शन ये है और मैं किसी और डायरेक्शन में 5 मीटर सेकंड की एक और वेलोसिटी बनाऊं, these two are not the same because they have a different direction. सही है? And since we say that they have a different direction, we say that these velocities are different because अभी हमने पार्टी में यही जवाब दिया, velocity is a vector, it has direction as well as magnitude. Even though उसका magnitude सेम है, अगर उसकी डायरेक्शन डिफरेंट है तो वी से वेलोसिटी भी डिफरेंट है. ओके, सो इफ यू लुक एट द सैटेलाइट नाउ, अगर इस पोजीशन में अगर सैटेलाइट की मैं वेलोसिटी बनाऊं तो वो कुछ ऐसे है, टेंजेंट टू द सर्कल. अब जब मेरी सैटेलाइट यहाँ पे आएगी तो उसकी वेलोसिटी कुछ ऐसे होगी. जब मेरी सैटेलाइट यहाँ पे आएगी तो उसकी वेलोसिटी कुछ ऐसे होगी. सो बेसिकली योर वेलोसिटी is constantly changing direction. And since it's changing direction, we'll say that the velocity is changing. And whenever velocity is changing, acceleration by definition, acceleration का मतलब क्या है? Rate of change of velocity. So अगर velocity की direction change हो रही है मतलब velocity change हो रही है. और अगर velocity change हो रही है तो इसका मतलब है कि चीज accelerate कर रही है. So in terms of velocity, okay, first we will say velocity keeps changing डायरेक्शन. इन दिस सिचुएशन हमारी वेलोसिटी की जो डायरेक्शन है वो कम्प्लीटली हर वक्त बार बार चेंज हो रही है. अब हमें पता है एक्सेलरेशन इज नोन एज एक्सेलरेशन इज रेट ऑफ चेंज ऑफ वेलोसिटी. सो इफ वेलोसिटी की डायरेक्शन चेंज हो रही है तो इसका मतलब वेलोसिटी चेंज हो रही है. दैट्स व्हाई सैटेलाइट इज एक्सेलरेटिंग even though उसकी speed constant है. But speed and velocity are two different things. On figure 1.1, draw an arrow starting on the satellite to show the direction of the acceleration. Again, exactly इसी तरह का सवाल हमने पीछे किया था, but उसमें उसमें भी हम सैटेलाइट की क्या बना रहे थे? Force, acceleration. So just to reiterate, velocity is always tangent to the circle. Force is towards the center always, and acceleration is also towards the center. तो हम यहाँ पे acceleration का arrow बना रहे हैं. Force हमसे नहीं मांगी भी, तो मैं force वाले word को यहाँ पे remove कर देता हूँ. ठीक है? This is known as the centripetal acceleration. Okay. So last part. As the satellite orbits the Earth, it experiences a force due to gravitational attraction. State and explain whether this force does work on the satellite and state whether the energy of the satellite is affected. Again, यही exact सवाल हमने पीछे किया था. Now we know that work is not done on the satellite because force की direction ये है और satellite की direction ये है. Force की direction यहाँ पे यूँ होगी और satellite की speed जो है वो इस direction में होगी. So force is perpendicular to velocity of the satellite. So no work is done. Secondly, work done जब भी होता है उसी वक्त एनर्जी ट्रांसफर होती है. Work done basically means transfer of energy. तो अगर आपका वर्क डन जीरो है तो आपका ट्रांसफर ऑफ एनर्जी भी 0 जूल्स है. So we'll say there is no transfer of energy. Again, there is or they are asking state whether the energy of the satellites is affected. Obviously, if there is no energy transfer to the satellites, we'll write that energy of satellite is not affected क्योंकि उसके ऊपर कोई वर्क नहीं हो रहा, उसके ऊपर कोई एनर्जी ट्रांसफर नहीं हो रही. ओके, So these are all the questions that we needed to do for kinematics and dynamics chapter. तो इनसे आप रेफर कर सकते हो जब भी आपको कोई क्वेश्चंस जो है वो करने में प्रॉब्लम हो रही है। अल्लाह हाफिज।